Welcome everyone. I am Dr. Manoj Kumar Sharma, Associate Professor, ITS College of Pharmacy, Muradnagar. This is the lecture number 21, Introduction of Research, Part 2. That means it is the continuation of the Introduction of Research, and the course for this lecture is Bachelor in Pharmacy, and the subject is Biostatics and Research Methodology. The subject code is 801T. and the university is Dr. APJ Abdul Kalam Technical University, Lucknow. The contents or the objective of present lecture is experimental design techniques, and the second is plagiarism. Now, experimental design is the process of planning a study to meet specified objectives. Planning an experiment properly is very important in order to ensure that the right type of data and a sufficient sample size and power are available to answer the research questions or research problems of interest as clearly and efficiently as possible, because the validity of an experiment is directly affected by the construction and execution. Attention to experimental design is extremely important. What are the basic principles of experimental design? There are three basic principles behind any experimental design. First is randomization. Randomization is the random allocation of the treatments to the experimental unit. Here randomization means not at random. Random means everybody have equal chance to select. So, in randomized, to avoid confounding between the treatment effect and other unknown effects. Second is replication. Replication, the repetition of a treatment within an experiment allows to quantify the natural variation between experimental units, and it also allows to increase the accuracy of estimated effects. So, replication kya hai? Replication is the repetition of treatment within an experimental experiment. Third, the basic principle of experimental design is local control, and it can be done by controlling as much possible the condition in the experiment. A classical example is the grouping of similar experimental units in blocks using non-characteristic properties of the experimental units to explain variation. For example, inclusion of the block effects in the statistical model. Now, what are the components of experimental design? The first is a response variable. Response variable, the property of prime of interest that is measured and that you want to do in a study. For example, grain yield, plant height, okay, or you do a experiment to develop a drug to control the blood pressure. So, then the blood pressure is the response variable. Second component of experimental design is one more or explanatory variable. The property or properties that you think will affect the response variable and that you want to investigate. There are two major type of explanatory variable. One is factor and second is treatment factor. Factors are the categorical explanatory variables classifying each observation as belonging to a specific group. Each group of a factor is called factor level, and a distinction can be made between them. The treatment factors with the level, there are direct of interest that we want to compare. So, treatment factors with level that are of direct interest that we want to compare. For example, variety with levels 3 variety, variety A, variety B, variety C. So, A, B, C are 3 factors and the level are variety. Now, another term is blocking factor, factor with the levels that are not of direct interest, but that are important to control variation in the experiment. So, are part of the experimental design, for example, blocks. Next is covariate. It is a continuous explanatory variable that quantifies some properties of each observation on a continuous scale. Again, we can make a distinction between covariates that are of interest. For example, the amount of nitrogen in kilogram per hectare when you want to investigate the effect of nitrogen, say on grain yield, or covariate are used to correct the for difference between the experimental units that are not related to the treatment. That means, it reduces the experimental error. In terms of experiment, we need to define some following terms. First is treatment. Treatment is what we want to compare in the experiment. It consists of the levels of single factor, a combination of levels of more than one factor, or a different quantify of an explanatory variable. Next is experimental unit. It is the physical unit that receive a particular treatment. For example, a plot in the field, it is a experimental that the allocation of a treatment to a particular experiment unit is at random. Next is measurement unit. Measurement unit is the level of at which observation are made, usually one measurement per experiment unit, but it is possible to make more than one observation within a single experimental unit, for example, in repeated measures of experiment. Another term is replication. Replication is the number of independent instances of a treatment that occur within an experiment, that is, several experimental units receive the same treatment. And next is block. Block is a group of experimental units that show some similarities, homogeneity between each other. The random allocation of treatment to units within block reduce the experimental error. We remember, we reduce the experimental error by the random allocation of treatments to units within a block. Next is sampling unit. The sub-object that is measured in an experiment is called the sampling unit. This may be different from the experimental unit. It referred from statistical design G. Gessela, Campaign and Hall, and this is published in 2008. Suppose some varieties of fish food is to be investigated on some species of fishes. The food is placed in the water tanks containing the fishes. The response of the is the increase in the weight of fish. So, response variable is increase in weight. The experimental unit is the tank, as the treatment is applied to the tank, not the fish. We remember, the experimental unit is tank, because we apply treatment to the tank, not fish. Note that if the experimenter had taken the fish in hand and placed the food in the mouth of fish, then the fish would have been the experimental unit, as long as each of the fish got an independent scoop of food. So, be noted in this example. I again read this, I explain this. Suppose some varieties of fish food to be investigated on some species of fish. the food is placed in the water tank containing the fish, the response is the increase in the weight of the fish. So, in this example the experimental unit is tank, because we apply treatment on tank, not fish. The response variable weight of the fish, but we giving the treatment in tank, because we giving the food in the tank, not for each fish. So, we remember here the treatment experimental unit is tank in this example. Now, there are different types of design. First is completely random design or CRD. The CRD is the simplest design. Suppose there are V treatments to be compared, all experimental or units considered the same and no diversion or grouping among them exist. In completely randomized design, the V treatments are allocated randomly to the whole set of experimental units without making any effort to group the experimental units in any way for more homogeneity. In CRD, the design is entirely flexible in the sense that any number of treatments or replication may be used. The number of replication for different treatments need not be equal. We remember the replication for different treatments it generally not equal. They may vary from one treatment to treatment depending on the knowledge or if and on the variability of the observation on the individual treatment as well as on the accuracy required for the estimate of individual treatment effects. So, we remember if we have different number of treatment, then the number of replication will be different for different treatment, and the number of replication depend upon the variability in the individual observation or individual treatment effect. Suppose there are 4 treatments and 20 experimental units, then and the treatment 1 is repeated, for example, say 3 times is given to 3 experimental units. The treatment 2 replicated say 5 times and it is given to 5 experimental units, and the treatment 3 is replicated, for example, or say 6 times and is given to 6 experimental unit. Then as in this example, finally, the treatment 4 is replicated is 20 minus 6 plus 5 plus 3, because the total number of experimental units are 20 and we already 3 experimental units for treatment 1, 5 experimental units given for treatment 2 and 6 experimental units already given for treatment 3. So, 6 5 plus 3, 6 5 11 plus 3, that is 14. So, we have 14 already allocated by treatment 1, treatment 2 and treatment 3. So, treatment 4 is replicated to 20 minus 14, this will be equal to 6 times and it is given to remaining 6 experimental unit. So, you see in this example the number of replication for each treatment are not equal, they may be vary to treatment to treatment. Okay. I again ask, as the 20 number of total experimental unit, one is replicated 3 times. So, it allocated to 3 experimental unit, treatment 2 is replicated 5 times. So, it given to 5 experimental unit and 6 is replicated to 6 times, treatment 3 is replicated to 6 times. So, it is given to 6 experimental unit. So, how many number of replication for treatment 4? So, the number of replication for treatment 4 is 20 minus 20 minus 20 minus 6 plus 5 plus 3, this will be equal to 4, 6. So, number of replication for treatment 4 is 6. So, they all 4 treatments have different number of replications. All the variability among the experiment unit goes into the experimental error. CRD is used when the experimental material is homogeneous and CRD is often inefficient, but CRD is more useful when the experiments are conducted inside the lab. We remember complete random design is helpful when we do our experiments in the lab. CRD is well suited for the small number of treatments and for the homogeneous experimental material. So, when we have homogeneous experimental material and small number of treatments, we should use completely randomized design. The layout of CRD. Following steps are needed to a CRD. Divide the entire experimental material or area into the experimental units. First, we divide the entire experimental material or area into the number of experimental unit. Then fix the number of replication for different treatments in advance for given number of available experimental units. No local control measure is provided as such, except the error variance can be reduced by choosing a homogeneous set of experimental units. That means, experimental units should be homogeneous. Procedure: let we have V treatment are numbered from 1 to 3 up to V and Ni be the number of replication required for the treatment such that summation Ni equal to n. So, select n1 units out of n units randomly and apply treatment 1 to the Ni units. Note, this is how the randomization principle is utilized CRD. Then select n2 units out of n minus n1, we select n minus n1 n2 units from n minus, because we already select n1 units from n. So, remaining units are n minus n1, then we select n2 units from n minus n1 and apply treatment to these n2 units. Continue with this procedure until the treatment have been utilized. This process continue with this procedure until all the treatment, we remember all the treatment have been utilized. Generally, the equal number of treatments are allocated to all the experimental units unless no practical limitation dictates or some treatments are more variable and are more interest. A completely random design, which is the simple type of the basic design, may be defined as a design in which the treatment are assigned to experimental units completely at random. That is, the randomization is done without any restrictions, completely at random. This is the randomization is done without any restriction. The design is completely flexible, that is, any number of treatments and any number of units per treatment may be used. Moreover, the number of units pre-treatment need not be equal. A completely random design is considered to be most useful in situation where the experimental units are homogeneous. An example of experimental layout of CRD: for example, we have 4 treatments A, B, C, D. So, first we assign C, A, B, D in another C, B, C, A, then A, D, D, B. So, in this we repeated each 3 times. We have 4 treatments A, B, C, D, and we repeated each 3 times. That means, A have 3 replication, B have 3 replication, C have 3 replication and D have 3 replication. So, you see here 1, 2, 3, these are 3 replication. For C, A 1, 2, 3, it has also 3 replication. So, we repeated each treatment 3 times in this design. Thus, the data set is arranged is as follows. Here we write treatments, that is treatments are 1, 2 up to V, and the allocation is y 1 1, y 2 1, y v 1. Another next is y 1 2, y 2 2, y v 2, y v 2, and last is y 1 n 1, y 2 n 2 and y v n v, and this is for first treatment, this is for second treatment and this is for vth treatment. So, data set is arranged in this way in CRD, and this is a table for block design. For example, we have 4 blocks, block of 4, then we have 1 2 3 4, 3 2 1 4, 3 4 1 2, 2 3 4 1, 4 3 2 1, like this. And if we have block 5, so it may be 4 2 3 1 5, 4 5 3 2 1. So, we allocate according to this. This is the randomization in block. Now, we read randomized block design. This is the another type of design. If a large number of treatments are to be compared, because CRD is applicable for a small number of treatments and the experimental units are homogeneous, then we apply CRD. But if we a large number of treatments are to be compared, then a large number of experimental units are to required. This will increase the variation among the responses, and CRD may not be appropriate to use in such case when the experimental material is not homogeneous. Be remember, as in CRD the experimental material or experimental units are homogeneous, okay, and we have a small number of treatments, but if the treatments are increased, then we need more experimental units and the experimental material is not homogeneous, or you can say they are differ to each other or heterogeneous in nature, and there are V treatments are to be compared, then we apply randomized block design. So, if the experimental material is not homogeneous and V treatments are to be compared, then it may be possible to group the experimental material into block sizes of V units, and blocks are constructed such that the experimental units within a block are relatively homogeneous and resemble to each other more closely than the units in the different blocks. If there are we have B such type of blocks, we say that the blocks are at B levels. Similarly, if there are V treatments, and we say that the treatments are at V level. So, if we have B blocks, then they have B level, and if we have V treatments, then they have V level. This is the layout for the randomized block design. The response from the B level of blocks and V levels of treatment can be arranged in a two-way layout. The observed data set is arranged as follows. Here are the treatment factors, and we have and we consider it is a factor B. Treatment we consider a factor B, and blocks consider a factor A. So, we have two factors, and factor B have V level, because we have V type of treatments, first treatment, second treatment, jth treatment and Vth treatment, and blocks have B levels. It may be 10, it may be 20, so it have B levels. So, factor B have V levels, it have V level and it have B level. Now, and this is the, so y11, y12, that means first level of factor A and second level of factor B. Then yij, that means first level of factor A and jth level of factor B, and last is y1b, and this is the block totals. Suppose the total of this is B1, B2, Bi and Bb, and this is the grand total. So, this is the layout of the randomized block design, and here we have treatments total. In here we have block totals and here we have treatments total. So, if we total with column wise, we get the treatments total, and if we get the sum of row wise, then we get the block totals. For example, Valerie J. Aston and John H. M. called statistics glossary via this. A researcher is carrying out a study of the effectiveness of 4 different skin creams for the treatment of a certain skin disease. He has 80 subjects and plans to divide them into treatments group, 4 treatment groups of 20 subjects, each using a randomized block design. The subjects are assessed and put in blocks of 4 according to how severe their skin condition is. The 4 most severe cases are the first block, the next 4 cases in the next second block, and so on the 20th block. The 4 members of each block are then randomly assigned one of each or 4 treatment groups. Plagiarism is another term, is presenting someone else work or ideas as your own with or without their consent by incorporating into your work without full acknowledgement all published and unpublished material, whether in manuscript, printed or electronic form, is coverage under the definition. Plagiarism may be intentional or reckless or intentional under the regulation for examination. Intentionally or reckless plagiarism is disciplinary offence. The plagiarism is if we steal and pass off the idea or words of another is one type of plagiarism. To use another or production without creating the source, to commit literally theft, to present as new and original idea or product derived from an existing source. In other working, plagiarism is an act of fraud. There are different types of plagiarism. Complete plagiarism. Complete plagiarism is the most severe form of plagiarism, where a researcher takes manuscript or study that someone else created and submits it under his or her name. It is equivalent to intellectual theft and stealing. Second, source based plagiarism. Plagiarism may be because of the different types of source. For example, when a research reference a source that is incorrect or does not exist, it is misleading citation. Plagiarism also occurs then a research uses secondary source data or information, but only cites the primary source of information. Both these types lead to an increase in the number of reference sources. This is in turn increase the citation and the number of references. Third is direct plagiarism. Plagiarism or verbatim plagiarism occurs when another copies the text of another author word to forward without the use of quotation marks of attribution, thus passing it as his or her own. In that way, it is the like complete plagiarism, but it refers to section rather than all of another paper. This type of plagiarism is considered dishonest and it is called academic disciplinary action. Self or auto plagiarism. Auto plagiarism is also known self plagiarism is drug duplication happens when author receives significant portion of or previously published work without the attribution. This type of plagiarism is most likely to involve published research rather than university students. The severity of this kind of infecting is under debate depending on the copied content. Paraphrasing plagiarism. This published on Willy, the most common type of plagiarism. It is involves the use of someone else writing the some mirror change in the scientist and using it as one's own. Even he words differ, the original idea remains the same and plagiarism occurs. Logic program plagiarism may be more difficult to detect because it is intensely interlaid some real phrase or text within own research. It is also known as patchwork plagiarism and it is intentional or dishonest. Accident plagiarism, whether intended or unintended, there is no excuse or plagiarism and the consequences are often the same. However, plagiarism may be accidental if it occurred because of neglect, mistake or unintentional. So, there are some different types of plagiarism that are common in the research. To make content completely free from plagiarism, the writer should be plagiarism software. There are many 4 versions of an online plagiarism checker to check plagiarism in content. To provide original content, the writer should make the content face to face any column from any other published work. Thank you.